Welcome back to Java Internals Crashcasts. I'm Sheila, and I'm here with Victor to dive into another fascinating topic in our Advanced Topics season. Today we're continuing our chapter on performance and scalability, and we'll be discussing benchmarking concurrent code. Victor, are you ready to help our listeners become benchmarking experts?
Absolutely, Sheila. I'm excited to share insights on this crucial aspect of concurrent programming. Before we start, listeners should be familiar with basic concurrent programming concepts and have some experience with Java development.
Great point, Victor. Now, let's kick things off with a quiz question for our listeners. Here goes. True or false? When benchmarking concurrent code, running the same test multiple times always produces consistent results. Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a tricky one, Sheila. It touches on some of the core challenges in benchmarking concurrent code. I'm sure our listeners will be pondering over this throughout the episode. It's a great way to highlight the complexities we'll be discussing today.
Absolutely. Now, let's start with the basics. Victor, could you explain what benchmarking is and why it's particularly important for concurrent code?
Certainly, Sheila. Benchmarking is the process of measuring and evaluating the performance of your code under specific conditions. For concurrent code, it's especially crucial because concurrency introduces complexities that can be hard to predict. We benchmark to ensure our concurrent code is actually improving performance and scaling as expected.
That makes sense. It's like measuring an athlete's performance in different conditions to optimize their training, right? But how do we actually go about benchmarking concurrent code in Java?
Great analogy, Sheila. For Java, one of the most popular tools for benchmarking is JMH, which stands for Java Microbenchmark Harness. It's designed to handle many of the pitfalls associated with benchmarking, especially for concurrent code. Other tools like Visual VM can also be helpful for profiling and identifying bottlenecks.
JMH sounds interesting. Could you elaborate on how it helps with concurrent code specifically?
Certainly. JMH is aware of common issues in concurrent benchmarking, such as false sharing, dead code elimination, and coordinated omission. It provides annotations and settings to control thread count, warm-up periods, and other factors that can affect concurrent performance. This helps ensure more accurate and reliable results.
That's fascinating. Now, when we're benchmarking, what exactly are we measuring? Are there specific metrics we should focus on?
Great question. The main metrics we typically look at are throughput, operations per second, latency, time per operation, and scalability, how performance changes with more threads or cores. For concurrent code, we're often particularly interested in scalability. Does adding more threads actually improve performance?
I see. So, if I understand correctly, we might use JMH to run our code with different numbers of threads and compare the throughput. But surely it can't be as simple as just running the benchmark once for each configuration.
You're absolutely right, Sheila. One of the biggest pitfalls in benchmarking, especially with concurrent code, is not accounting for variability. We need to run our benchmarks multiple times and look at statistical measures like the mean and standard deviation. JMH helps with this by allowing us to specify the number of iterations and forks.
That reminds me of a story I heard about a major Java library that had a performance regression. They only caught it because of their thorough benchmarking process. Do you know of any similar real-world examples?
Absolutely. One great example is the improvements made to Java's concurrent hash map over the years. Benchmarking revealed that the initial implementation didn't scale well for certain usage patterns. This led to significant optimizations in Java 8, which were again verified through careful benchmarking.
That's a great example of the importance of benchmarking. Now, I'm curious about best practices. What should developers keep in mind when benchmarking their concurrent code?
Excellent question. Some key best practices include 1. Always warm up your JVM before measuring. 2. Be aware of and control for external factors like CPU frequency scaling and garbage collection. 3. Benchmark on hardware similar to your production environment. 4. Don't forget to test with realistic data and workloads. 5. Be skeptical of results and always try to understand why you're seeing certain numbers.
Those are great tips, Victor. It seems like there's a lot to consider. Is there a simple way for our listeners to remember the most critical aspects of benchmarking concurrent code?
Absolutely, Sheila. Here's a simple mnemonic. Wars, warm-up, analyze variability, realistic scenarios, skepticism. If you remember these 4 points, you'll be well on your way to effective concurrent code benchmarking.
Wars. I love it. That's a great way to remember the key points. Now, before we wrap up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly. The answer to our quiz question is false. When benchmarking concurrent code, running the same test multiple times does not always produce consistent results. This is due to the non-deterministic nature of concurrent execution, system load variations, and other factors. That's why it's crucial to run multiple iterations and analyze the statistical distribution of results.
Thank you, Victor. To summarize today's episode, we've learned about the importance of benchmarking concurrent code, explored tools like JMH, discussed key metrics to measure, and covered best practices including the WARS mnemonic. Remember, effective benchmarking is crucial for ensuring your concurrent code is actually delivering the performance improvements you expect.
Absolutely, Sheila. And in our next episode, we'll be diving into the fascinating world of the Java memory model. It's a topic that's crucial for understanding the behavior of concurrent code at a deep level.
I can't wait, Victor. And to our listeners, thank you for tuning in to Java Internals Crashcasts. If you've enjoyed this episode, please subscribe and leave us a rating. Your support helps us continue producing this content. Until next time, happy coding. Happy